let's consider the intersection of a line and a curve. Okay, so perhaps we have some quadratic curve and a straight line, and they interact with each other in some way. And this can happen in one of three ways. So here's a quadratic curve, and here's a straight line. And if I move the straight line here, it's clear to see that we have two distinct points of intersection. Okay, the graph intersects each other at two places. Now, if either the straight line or the curve's equation had to change, this interaction could change. So for instance, if we moved the straight line there and the quadratic over here, we now have one point of intersection, right, which we also call a tangent. And again, if we move the quadratic or the straight line, at this scenario we have no points of intersection, so they don't ever intersect each other. Now this is a graphical look at it, and there are also the algebraic way of looking at this. So perhaps we had the equation of the parabola, and it was given as x squared minus 3x minus 4. And so we have the straight line at y equal to x minus 6. Now, assuming we don't know what these two functions look like graphically, maybe we get asked to find the 2 points of intersection, or if there are any points of intersection. Now, for points of intersection to occur, they happen when the two equations are equal to each other. And so we would equate them together. So we would make x squared minus 3x minus 4 equal to x minus 6. And now we would just solve for x. So we would rearrange x squared minus 4x plus 2 equal to 0. And now we just have a new quadratic equation to solve for. And it works in the same way that we looked at for the roots of a quadratic equation. So we could use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. We could use the quadratic formula to find the x-coordinates of these 2 points of intersection, or 1 or 0 depending on the two equations. So in summary, basically we can have one of 3 different scenarios. Okay, we can have 2 points of intersection, 1 point of intersection, which is a tangent, or no points of intersection. And just like the roots of the quadratic equation that we looked at previously, if we consider the discriminant of this new equation, where we've equated the two equations together, exactly the same rule applies. So if b squared minus 4ac is greater than 0, we'll have 2 points of intersection. So the discriminant of the new equation. Okay, that's after we've equated the two together, not before. And likewise, if b squared minus 4ac is equal to 0, then we will have 1 point of intersection. And finally, if b squared minus 4ac is less than 0, we'll have no points of intersection. So if you consider the discriminant of the combined equation, if the discriminant is less than 0, we know that the two graphs don't intersect each other at all. Now, we can also just combine these two. If we were asked to find if there were any points of intersection, or then together, as long as the discriminant is greater than or equal to 0, we will have at least 1 or 2 points of intersection. Okay, so let's look at some examples. Here we have the equation of a straight line and a quadratic, and we want to find the values for k, for which this is a tangent to the curve, so only 1 point of intersection. Okay, so if you consider what we're doing, as we change k, we are shifting vertically the straight line up or down, and depending on how high or low we shift it, it could either intersect at 2 places, 1 or even 0. So let's first of all equate the two equations together. Right, for points of intersection, they first of all have to be equal to each other. Okay, and we'll just rearrange the equation. So we're going to group like terms. So we have x squared, and we're going to have minus 6x plus 4 minus k equal to 0. So we have our a, our b and our c term. And we can say for a tangent, b squared minus 4ac must be equal to 0, because we want two roots that are the same. And so we're just going to put those into our equation. So we'll have minus 6 squared minus 4, a is just 1, c is 4 minus k equal to 0. Here we'll have 36 minus 16 plus 4k equal to 0. And I can just move, we can have 4k equal to, well, we'll have 20, take it to the other side, negative 20, so k equal to negative 5. Okay, so when k is equal to 5, that straight line will be in a position where we only have one point of intersection. Okay, let's look at the next example. Here we say find the range of values for which this straight line and this quadratic have two distinct points of intersection. So like before, we will equate these two together and get our a, b, and c terms. So we need to rearrange a little bit. Kx squared minus x. If I move the 5 over, I'm going to get minus 1 equal to 0. So again, we have our a, we have our b, and we have our c term. So for two distinct roots, b squared minus 4ac must be greater than 0, must be positive. So let's just substitute in. We're going to get b squared, which is just minus 1 squared minus 4 times k times minus 1 is c, greater than 0. So I'm going to get 1 plus 4k greater than 0. And so k will be greater than, if I move the 1 over to the other side, it'll become negative, and divide by 4. K must be greater than negative 1/4. If it's greater than that value, we'll have two distinct points of intersection. Okay, one more example. They ask us to find the values of k, and this is now we're changing the gradient of the straight line for which the 2 points or the two graphs don't intersect each other. So as before, equate the two together. And now we're going to group like terms together on the left hand side. So we'll have x squared minus 2x minus kx, and we're going to get plus 4 equal to 0. I'm going to factor out the x squared so I can get my b term, so minus x, and we'll get 2 plus k plus 4 equal to 0. Here I have my a, there's my b, and there's my c. And this time we can say, well, we want for no roots, we know b squared minus 4ac must be less than 0. If it's less than 0, it'll be negative, and we can't work with the square root of negative numbers yet. There will be no real solutions. So my b squared is this k. I'm just going to rearrange it to k plus 2 squared minus 4 times 1 times 4 less than 0. And now we're just going to solve the quadratic inequality. So k squared plus 4k plus 4 minus 16 is less than 0. K squared plus 4k minus 12 is less than 0. And we can now factorize. So I'm thinking we're going to do 6 and 2. So k plus 6, k minus 2 less than 0. So let's consider the critical values will be when when k is equal to negative 6 or k is equal to 2. We can draw our point on a straight line. And now we need to consider the inequality we're solving for. We want to know when this value of k is less than 0, and we can visually see that is between those two values. And so our solution will be negative 6 is less than k, which is less than 2.